started the adjoint theorem, and we have seen that for simple operator du by dx square, we have the boundary conditions B of we call as B operator, right? B equals to 0, and in that case we have seen on what basis A equals to L star and B equals to D star. So the operator is adjoint. For adjoint operator, we have seen A equals to L star and B equals to D star. This is the main problem with the boundary condition. This is the adjoint problem with the adjoint boundary condition. Adjoint problem, the problem will be d2b by dx square is the adjoint operator. If it is eigenvalue problem, d2b by dx square minus lambda b, and the corresponding boundary conditions b star b star will be such that b star b and b star operator and b operator would be the same. In that case, we can say the operator is adjoint operator. Then we started talking about generalized operators, which is A0x. So the generalized boundary condition, boundary eigenvalue problem, what we have taken. It's a generalized case. It will not be known as lambda u, which is A0x d3u by dx square plus A1x du dx plus A2x u equals to minus lambda A3x. That is a generalized problem. And L operator is A0x d2 by dx square plus A1x ddx plus A2x. This is the operator. So in this kind of, these are most generalized eigenvalue problem in the functional space. The most generalized eigenvalue problem in the functional space. Okay, and so if any such generalized operator is given, and if you want to know that the operator is self-adjoint or not, what is the operator of self-adjoint operator? You know that from the vector space we found that eigenvalues are to be real and eigenfunctions are always orthogonal. That's why you need to find out the operator is self-adjoint or not. And if the operator is non-self-adjoint in functional space, there is no way to make it self-adjoint. Okay, there is a way to make it self-adjoint. There is a way in vector space also. We have not done that because we don't need actually, because we know that even for non-self-adjoint operator, the eigenvectors are orthogonal to the conjugate problem, to the A star problem, and in that case we have the bi-orthogonality property. So but here we don't have to do all this bi-orthogonality everything. It is possible to convert non-self-adjoint to self-adjoint, and we can proceed accordingly. Okay, so when we apply adjoint theorem, we have inner product LUV equals to U L star V, and we have JUV, which is called as bilinear concomitant. And for adjoint theorem to be valid, your bilinear concomitant has to be 0. Sometimes you use bilinear concomitant also when you want to solve the problem. In the later on, we will see that even without being bilinear concomitant 0, we can actually solve the problem. So that is specifically called as finite Fourier transformation. We will actually discuss in later part of the course. But this will be useful. Whatever we do in this functional space, as we have seen in vector space, we are using adjoint theorem. So what actually we have done, left hand side we have inner product LUV, which is integral A to B. We have A0x d2u dx square plus A1x du dx plus A2x u v dx. Right? And we have got three terms: integral A to B, A0x d2u dx square, v dx plus A to B. We have A1x du dx v dx plus integral A to B A2x du v dx. Okay. So these are the basically term 1. term 2 and term 3. I think we have done yesterday term 1, right? So term 1, what is the result from the term 1? Which is, there are two terms with the boundary conditions a to b. First two terms what? du dx, a0x, b a to b. Am I correct? Next term is u ddx of a0x, b a to b plus a to b u d2 by dx square a0x b dx. First term. Second term, how many terms will be there? Only two terms will be there. One will be coming as boundary term. This is basically called as boundary. Because only the boundary points it has the value. Other terms, other nodes it doesn't have the value. So these are called as boundary terms. These are called as boundary terms. Second term is plus u a1x b a to b minus integral a to b u dx a1x b dx plus third term will remain unchanged, which is a2x u b dx. Right? Now, if you want to look at, so this term is okay, but so these are two terms. I want more on that because so far we don't know how this term. Because you remember that this is the way we have split. So can we split further? So this term and this term requires further attention. These two terms requires further attention. Let's look at these two terms, which requires further attention. So d2 by dx square a0x b. What should I write? We can write this as ddx of a0x b, and then from here two terms will be coming, ddx of a0x b prime plus b a0 prime x. Then what will come? So then each of these two terms you have to do like this, ddx of a0x b prime plus b of a0 prime x. What is that? What do you finally get? You will get a0x d2b dx square plus db dx a0 prime x plus dv dx a0 prime x plus b a0 double prime x. Am I correct? Yes. Similarly, this term, what is that? Yeah, this is a term. So it has two terms, right? a1x b prime plus b a1x prime. Okay. So finally, what you get? You get the JUV. JUV will be constructed from here, here, and here. There are three terms for JUV, right? There are three terms for JUV. Am I correct? So I am just collecting these three terms, and later on I will be talking about integral a to b. What is, so it is coming like this. X of this term we have u. U should be taken out. And why I am taking out? Because if you look at adjunctive, inner product LUV is equal to JU plus inner product UL star V. So if I say UL star V, U should be taken as out. Then L star will be having the actual operator, right? So what is L star V? What is L star V now? Which is very simple. To collect the term and tell me the answer. I have given the terms here. What is that? First to write the higher order derivative. What? First term is what? It's coming a0x d2b dx. What are we talking about? We have done this one, right? This is opened up 4 terms. This opened up 2 terms. We have to combine and give the answer here. We have done it, right? Remember that your A operator is a0x d2 by dx square plus a1x ddx plus a2x. We have to get similar kind of operator L star. That's your objective. Because always whatever you do, we have to compare the L star. Whether it's L equals to L star or not. In that case, that's why I have done this kind of operation. Otherwise, why should I do that? What is this in the bracketed term? What is this in the bracketed term? Anybody can give the answer. In the bracket, what is happening? What's the term? You collect the term and get me the answer. It's so simple. You collect the term and get me the answer. I mean, you don't know. What is this, man? It is actually 10 plus calculus. I have done all the steps. This is complicated, this is nothing. A naught x v double prime plus a1x plus a1x you should be boss. You are just dictating from LU prime double prime. Don't text. That's why I don't ask anybody in the class, because I know that you are not interested in these kind of courses. Yes, Vasudha. That's why I'm all the time depending on him, because other people are not able to participate in the class. Plus minus a1x. Yes, excellent. B double prime, B prime, yes. Then plus a1 prime, are you sure? Plus a1 prime?
Minus a1 prime.
So there is what is the term available? A0 double prime x is available. Minus a1 prime x plus a2x bracket close. Simple. I have given all the steps. Both these steps are here. Your job is to collect all the steps and give me the answer. That too, Amit was actually talking arbitrarily. I don't know what kind of people I am teaching in the class. Did you understand this step? This is called kindergarten way of teaching, the advanced level of mathematics. Some of you guys actually complain, oh, we didn't have good teachers in our college. But I think the good teachers also have no role to play, because you don't want to learn anything. That's the problem. If you don't want to learn anything, teachers cannot do anything. So, what is your L star then? What is your L star? What is your L star then? Who can dictate L star? What is your L star? L star operator, what is that? We have done so much of operator so far. It is quite obvious from the board. What is the L star operator? a0x d2 by dx square plus 2a0 prime x minus a1x ddx, then plus a0 double prime x minus a1 prime x plus a2x, and that's it. A is not equals to L star. So, of course, the generalized operator will not be such that A equals to L star. Here we found that A is not equals to L star. So, what is the condition when A equals to L star? When A equals to L star? We have, so for A equals to L star, this guy has to be A1x and this guy has to be A2x. In that case, we can say L equals to L star, because this is same A0x. If you compare L, you have A0x here, A1, A2. You got A0, fine. You didn't get A1, you didn't get A2. So, for being L equals to L star, what we have to do? We have to find 2a0 prime x minus a1x equals to a1x and which gives you A1x equals to A0 prime x. If this is the relationship, then in that case you can say, okay, up to this is everything okay. Last one, which is A0 double prime x minus A1 prime x plus A2x equals to A2x. And if you look at A0 double prime x is A1 prime x, that means if this is satisfied, this is automatically satisfied, because this and this will get cancelled and A2x equals to A2x. Am I correct? Yes or no? So the bottom line is, if this is the situation, A1x is which is nothing but A0 prime x, then in that case you can say that L is L star, and in that case if B is equals to B star, so in that case L equals to L star, and if B equals to B star, then you can say operator is self-adjoint. Then you can say operator is self-adjoint. Okay. So when an operator is self-adjoint, you can write, or there is a procedure if the operator is non-self-adjoint, how to convert it self-adjoint, or how to write in a compact fashion. So we are going to discuss something called the Sturm-Liouville problem. Have you heard about this? The Sturm-Liouville problem? Okay. So let's look at, so we will try to write an operator ddx px ddx plus px. If you look at, if you write a generalized operator in this fashion, you can see that A0 and A1 are actually following this relationship, right? Px d2 dx square plus dp dx ddx, right? And in that case dp dx is nothing but derivative of the first term, and this operator by default is self-adjoint operator. Did you get my point? Yes or no? That's why your class no responsibility. If I catch somebody, he will say I didn't understand. That's why I don't take many responsibility whether people understand or only one or two people will find, because nobody is asking any question. That's why I don't take any responsibility. Did you understand what I said? Yes or no? Yeah, see, after so much of time you think I'm a barking dog. After so much time you say no. What actually happens? Lu ddx of px du dx plus qxu. You understand this step? Yes or no? Okay. So px d2u dx square plus dp dx du dx plus qxu. Did you understand this step? If this is a0x, this is a1x. Did you understand this step? What's the relationship between a0 and a1? That's why I said this is by default a self-adjoint operator. If a0 equals to a1 prime, not self-adjoint, by default, in this case we can say it equals to self-adjoint. I don't say self-adjoint because self-adjoint means we need to have b equals to b star also. That depends on boundary condition. But this satisfies one step, that a equals to self-adjoint. Right? Now let's look at how to write. Any operator is given, how to write in terms of this operator. So if you can write, so our objective is, we have Lu, which is a0x dpu by dx square plus a1x du dx plus a2x. If you can write like this, your problem is solved. If you can write like this, your problem is solved. That means you can say, okay, in this way, we can actually have a self-adjoint operator. One other interesting thing we are actually seeing from chemical engineering perspective, this has tremendous application in chemical engineering. For example, we have a heat transfer process, and the thermal conductivity is dependent on position because of a porous medium. And quite often you see this kind of equation. Have you seen this kind of equation in transform? Okay, so this by default is self-adjoint operator. So heat transfer process is such a nice process. It brings out the self-adjoint operator by default. So you can see our life is so simple in chemical engineering. Even for so much of complications, even this is a function of position. We can see this is nothing but this kind of operator, which is the self-adjoint operator. Okay, so what you we can write this one. So we can formulate about the eigenvalue problem. Eigenvalue problem we can write as a0x d2u by dx square plus a1x. So I write first equation is this first, second equation is the first equation, or I will write later to have second is the first, because this we discuss the first time. a1x d2 dx plus a2x u minus lambda a3x. Most generalized eigenvalue problem. You can't have much more generalized. Okay? Most generalized, and of course, as I said yesterday, we will be talking about linear operator. Non-linear operator is very difficult to do eigenvalue problem, and we don't go for non-linear operator. In that case, you have to go for the numerical matrix. And equivalently, you can write this problem as px d2u by dx square plus dp dx du dx plus qxu, we can say minus lambda wh. This is also one of the generalized eigenvalue problem when you write the operator as ddx of px ddx plus qx. For this kind of operator also you can have eigenvalue problem, which is I am saying minus lambda wh. Okay. Now my promise is what? This problem and this problem I correlate. If I can have one-to-one correspondence, then this entire thing can be converted to this type of problem. And in that case, we can say, okay, I can write my problem like this. So my operator, operator L equals to L star. I cannot say B equals to B star, but at least we can talk about L equals to L star. And once L equals to L star, your life is very, very simple. Because if you can prove B equals to B star, you can say my operator is self-adjoint. What is the one-to-one correspondence between the coefficients such that you can have the values of px and you can convert the entire thing to this type of operator? Let's compare equation 3 and 4 and see what is happening. Comparing equations 3 and 4, what you get? a0x by dx equals to a1x by dp dx equals to a2x by qx equals to a3x by wx. Can you say like this? I am saying that this can be converted to this. In that case, we can write a0x by px a1x by dp dx a2x by qx equals to a3x by wx. Essentially what I am saying, both these equations are the same. For example, I say x square plus 5x plus 6 equals to 7. ax square plus bx plus c equals to 7. So I can write x by a equals to 5 by b, 6 by c equals to a. Okay? So it could be 2x square plus 10x plus whatever. If you have some kind of d, for example, you can write 7 by 2. Okay? So in that case, this is valid for any of the multiples. So you can have 2x square plus 10x plus 12 plus equals to 40. Again, you have x square plus 5x plus 3. So both these equations are identical. I can write this way. Do you agree or not? Yes? So same thing I am saying. Both these equations are actually identical, right? Agreed? This kind of things you have done at the school level, right? If both the equations are actually same, then you can write 1 by A, 5 by B, 6 by C, or 7 by D. Okay? With that, what you can write? You can write dpx by dx by px equals to, I am taking, sorry, it should be equals to, which is a1x by a0x. What you get px is very simple, school level calculus. School level calculus. School level calculus. Exponential integral a1x. Am I correct? Yes, you understood. Okay. What is qx? Px you got. See, unknowns are px and qx. Of course, wx also you can get. So in that case, you won't write in terms of a0, a1. You will write px, qx, wx. In that case, you are making sure, okay, your operator a leaves, a is elsewhere. Okay? In that case, what? What are you getting? What is that? Qx equals to, in terms of px you will find out, right? A2. So px, a2x by a0x and wx, which is px, a3x by a0x. That means this equation can be converted to this equation, and you got the one-to-one coordinate. So a1 and a0. So if even if you don't have the self-adjoint stuff, you can actually equate the px, qx, wx, and you can write in this fashion. In that case, you can have still n equals to L square. So one of the interesting things we have done here, even whatever values you are actually having, you can, whatever values actually you are having, we can always talk about the self-adjoint operator. So we can talk in terms of n equals to L star. Okay. Next will be so now if you want to verify this self-adjoint or not, how will you do that? Of course, these are relationship, right? This is a relationship. Inner product A U B equals to L star B plus J U B, right? What is LU? Inner product A U B, which is integral, which is ddx of px du dx plus qx v dx. Am I correct? We have integral a to b ddx of px du dx v dx plus a to b qx u v dx. What you got? This is very simple. This you don't have to do anything here. What you can do here? What is the u and v? Remember that it is representing integral v du dx. That's what you have decided as capital V d of capital U dx. What is your capital U? This is your capital U and this is your capital B, right? Tell me the answer then. Tell me the answer. First step, at least you tell me. What's the first step? What's the first step? You should be doing very fast. What's the first step? What's the first step? First step, you will get the boundary term. First step is the boundary term. There is no question of integral because you have done already. Yes?
dx du by dx b into b.
Px du dx into b
Into b.
minus
px du by dx.
integral you won't say. That's what I'm saying. You are ignoring minus integral all the things. A to b
px du by dx.
px du dx
dv dx.
dv dx dx plus a to b qx uv dx. Next px du dx b a to b and then next step. Next is what is u, what is b? What is u, what is b? U is what? What is capital U, what is capital B? Du by dx is capital U? U is capital U, right? Capital B is what? P of x dv dx. Excellent. Tell me the answer then. Final answer. I will show the steps. I will show the steps. What's the next step then? Why you are so slow? Why you are so slow? Minus u dx dv dx a to b plus integral a to b u into ddx of p of x dv dx dx plus a to b qx uv dx. This is your JUV, bilinear concomitant. If you look at this, both the terms as u. So your operator is ddx of px dv dx plus b dx in the bracketed term, and that means L equals to L star. So that has been proved from here. So you can do it in the final step, that L equals to L star, and these are the bilinear concomitant. So next, actually, I am picking up one of the assignment problems. So you can get the assignment by today itself. Area is given as d2u by dx square minus du dx 0 less than x less than 1 with a boundary condition u0 equals to 0, u1 equals to 0. Our problem, we need only operator and boundary conditions. Generally, the differential equations are given in terms of operator and boundary condition. Then you can construct whatever way the non-homogeneous term will be. You can say d2 by dx square minus du dx equal to 0, or some function is, or some eigenvalue problem, same boundary condition. Depending on your right hand side, the problem could be called as homogeneous problem could be called as non-homogeneous problem could be called as eigenvalue problem. But any operator will be fine. You need to have associated boundary condition for that particular operator. What does it mean? My operator is a temperature. d2t by dx square minus dx. When you talk about temperature, at the boundary points, you know the temperature. Okay, this side is hot, this side is cold. When you talk about concentration, you know one part is impermeable. So dc by dx equals to 0. Another part, concentration is fixed, E equals to 1. So when you talk about this variable, this could be velocity for momentum transfer, Heat transfer, this could be temperature. Mass transfer, this could be concentration or reaction process. In that case, it is easy to find out the boundary condition. Without boundary condition, you cannot even have an operator. But in vector space, there is no such concept of the boundary condition. Vector space does not require any boundary condition. It is a matrix is actually defined and it takes care of entire domain. Okay. So the question is L star and B star. Calculate 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 L star and B star. How to calculate? How to obtain L star and B star? What's the step? Tell me. First tell the step before starting. Inner product LUV equals to JUV plus inner product U L star. Left hand side we start, which is integral 0 to 1 d to u by dx square minus du dx d dx. Final answer I want, because so many tough problems you have done. This easy problem. I have solved all tough problems. Now I am doing an easy problem. I have solved all tough problems. I have solved all the tough problems. These are all easy problems. This is an easy problem. What is the final answer? Combining two terms. What's the final answer? What is your JUV and what is the inner product? How many terms will be there in JUV? Any answer? No. This will give two terms. This will give three terms. d2 by dx will give two terms, no? In JUV, you do separate term 1, term 2. You do separate term 1, term 2. Yes. No, I just want JUV. Don't talk all nonsense. You just talk systematic. I can talk like in the class and go home. You won't be able to appreciate. So if I talk like the same way, I expect the same answers. Don't reply to me. I want a step by step. What is that? First step is what? du dx into v0 to 1. Next, minus u dv dx. In the exam, remember that I want all the steps. If you write like this, you will get extremely 0. Not even 0.5. Exactly 0.0 I will give. If you do like this, because I have to do all the steps. Okay, next step, plus integral 0 to 1 u d2 v dx square dx, then minus ub 0 to 1 plus 0 to 1 u dv dx dx. This term and this term will give jub. And what you get? Integral 0 to 1 d2 v dx square plus dv dx into u dx, and you can see clearly L is not equals to L star. Clearly L is not equals to L star. And what is your JUV? So to determine, so B star, that means if you want to calculate JUV equals to 0, if JUV equals to 0, you can calculate B star. If JUV equals to 0, then what will happen? Because our objective is to have AUB equals to L star B. That's our objective for a problem. And from that case, you can get calculate B star. That's our objective for the adjoint theorem. So to have adjoint theorem ready, or in fact, if you can have B equals to B star, it is possible to convert the operator L such that L equals to L star by star dividing problem what I discussed last. So in that case, B equals to B star is already happening. Okay, L is not equals to L star, but you can convert L by L star by the previous form, which is ddx of dx du dx. In that case, you can still have the adjoint problem, self-adjoint operator. So what is your B star then? So your JUB is du dx B at 1 minus du dx B at 0 minus u dv dx at 1 plus u dv dx at 0 minus uv at 1 plus uv at 0. What's the boundary condition prescribed? u0 equals to 0. It is going to be 0. u1 this is u1, this is going to be 0, this u0 also going to be 0. So these two terms are actually remaining, which you cannot cancel out, right? Yes, du dx is there, du dx is not prescribed at 1. So these four terms are going only except these two terms. And what I will do, these two terms will get 0. You understand why these terms are 0? Because u1 equal to 0. So this multiplication is 0. u0 equals to 0, this multiplication is 0. u1 equal to 0, this is 0. u0 equal to 0, this is 0. These four terms are going fine. First two terms, what shall I do with the first two terms to make it 0? If JUB is not equal to 0, we cannot talk anything about the self-adjoint operator. Because for the operator is self-adjoint, your rule is that inner product LUB equals to UL star B and L equals to L star, B equals to B star. Then only you can get, say, your operator is self-adjoint. And this is also seen in the vector space. Vector space JUB was not there, the extra complexity was not there. Here JUB is there. This is the condition for the self-adjoint operator, right? So in that case, definitely you have to put JUB equals to 0. What should be the condition? U by dx is not, you cannot do anything. See, you cannot say if u0 equal to 0, I can have this kind of function, right? Where u0 equals to 0, u1 equals to 0, du dx is 0? Of course not. Don't say that du dx equals to 0. You see the physics. On what condition this can be fixed? Okay, so you can actually simply select v1 and v0. Because it's a boundary condition for the v1 and v0, v1 equals to 0 and v0 equal to 0. This is the boundary condition to fix so such that this has to be 0. So the adjoint operator has become, what's the adjoint problem then? Adjoint problem L star, which is d L star b is d2b by dx square plus dv dx, and b star b is given as b1 equals to 0 and b0 equals to 0, right? And you can see here b equals to b star, but a is not equals to L star. B equals to b star, but a is not equals to L star. Now, how to convert? Now, this is a good indication. Only thing is remaining, this is not equals to. If I make it equal, then my problem is solved. Then how to select px such that I have the self L equals to L star or complete operator self-adjoint? What is my px? We have done it. What is my px? What is my px? You can directly calculate and give me the answer. What is my px? What is the px? What is px? E to the power? E to the power? Somebody says e to the power x, somebody says minus x, which is correct? What is your then L operator? You tell me L operator now. ddx of e to the power minus x du dx plus qx is 0, right? That means if I have an operator, a u is d dx of e to the power minus x du dx, u1 equals to 0, u0 equals to 0. In that case, we have a equals to l star, b equals to b star. This operator is self-adjoint operator. So instead of writing e to the by dx square minus du dx, I am writing the minus x du dx, and in that case, the operator is self-adjoint operator. In that case, the operator is self-adjoint operator. So understood, right? So how to convert a non-self-adjoint operator to a self-adjoint operator? Okay, I'll give another problem and leave the class. You can do it, and up to today's class is the syllabus. Syllabus of the second quiz is up to today's class. So next problem, problem number 2, which is dq by dx square. u0 equals to 2q prime 1 and u1 equals to 0. Okay? Find L star and B star. Find L star and B star. Find L star and B star to make it how to make it self-adjoint, or can you make it self-adjoint? Find L star and B star and comment on self-adjoincies. What may happen that you may see that you are able to make it L equals to L star, but still B may not be equals to B star. So in that case, you take all the effort to do all those, but your B is not equals to B star, you still may not have the self-adjoint operator. Thanks for attention. So I will be seeing you on next Tuesday, and I think if you can submit to me on Tuesday the nonlinear that assignment 6. Whoever will submit, I will see the number of problems being solved, and based on that I will give the bonus point, which could be the addition for your quiz 1, quiz 2 and all those things. So I want to see who can quiz some. Of course, if somebody copies, I will not give any kind of bonus point. Okay.